Welcome. I'm going to just walk you through the details about how to do the static and kinetic friction lab. Okay, so you're going to go ahead and start by opening the simulation. Okay, and as you can see here, you can choose the type of surfaces. So I'm going to go glass on glass just to be fun. And then you should start with a nice low mass. So I'm going to bring it down to the 100. Okay. All right. And so what's going on here is we have a glass block on a glass table. It's being pulled with this force probe. In a normal year, you would actually be doing this, right? And then it's going to record the force during the whole time, and then also graph it down here. Keep in mind a couple of things. Two things are going on. Before it starts to move, forces are balanced because it's not moving. And even the instant that it slips, forces are still balanced because the instant before it slipped, it was at rest. And then once it gets moving, they pull in such a way that it moves at a constant velocity. That's just what's happening in the lab. All right, so let's go ahead and see what happens. So if we hit start, you'll notice that the force is going up and up and up on the force probe, and eventually it starts to move. Okay, and if we look at the graph, what happened was as they pulled slowly, and we can reset this and do it again. All right, and I'm just going to watch the graph get made here. I don't know if I can get the graph and the thing showed kind of at the same time. Maybe I will. All right, so here comes, and before it moves, you get a steady, and then the instant it starts to move, it goes to this lower value, right? So all of this here is when it was at rest, and then here is once it's moving at a constant velocity. Let's look at that one more time. Okay, at rest, at rest, at rest, at rest. Then the instant it moves, it slips down to this lower thing. Now, what do you actually need to record? We need two pieces of data. One is the maximum static friction force, and that's this number up here. Okay, so I'd probably pick this little dot right here, whatever the maximum dot is. So, somewhere between 0.8 and 1 is the force. And then that is what I'm going to record in the friction lab right in this white column here. And if you notice, the way this is set up is the white columns are data that you record directly from the simulation, and the gray columns are calculated data. Okay, so to get this maximum static friction, it's this point right up here, this force. And then to get the kinetic friction force, that's what happens when it's actually moving. That's this value here. So kind of take an average of these values here and you put that in. All right. And then the mass is right here. Something to keep in mind. This mass is in grams. The chart is in kilograms. Okay. So in order to get from grams to kilograms, you're going to move the decimal 3 places. So 100 grams would be 0.1 kilograms. Okay, so you'll fill that in, fill in the maximum, fill in that average of when it's a constant rate. Okay, and then we've got to do the actual calculations. Okay, so one of the things you've got to do is calculate the normal force. Well, as we figured out in the pre-lab, the normal force is going to be perfectly balancing the gravity force because the block is not accelerating in the vertical direction for sure. So in order to find the gravity force, we're just going to use Fg equals mg. So you're going to multiply whatever the mass was, in this case 0.1 kilograms if you use that, times 9.81. And that will give us a negative force of gravity on the glass block. But because the normal force is upwards, I'm going to put that as a positive number. Okay. All right. So for example, I could put in right here 0.1 kilograms. Okay. And that is going to be that's going to actually look at data from this. Okay. Then I've got the, I'm going to say this is about 0.9. Probably 0.92 is the maximum static friction force here. And then for the kinetic friction force, I come down here, and that's going to be right around, I'd say, 0.4. So I come in and put this in here, 0.4. Now, to do the calculations, this here is going to be 0.1 times 9.81. So that's going to be 0.98. Okay, so I just got that from multiplying the mass times 9.81. And again, since the normal force is up, it's going to be a positive number. Then to find the coefficient of static friction, I'm just going to do whatever the force of static friction was. So that's 0.92 divided by the normal force, which was 0.98. You're going to actually put an actual number in there and not this thing, but I'm just showing you how to do it. And then for the force of kinetic friction, it's going to be the force you recorded, which was 0.4, over that same normal force, so 0.98. And again, you're not going to put these numbers in, you're going to put the actual numbers. So this is how you're going to do it. And then you're going to repeat this with different masses. So you're going to go back into here and play around, you reset it. Okay, maybe choose a new higher mass and then try it again. Okay, all right, and get that data. Okay, all right, so let's just talk about one other thing in the lab, and that's units. So forces are measured in newtons, so I put those in. Keep in mind that the coefficient of friction, which I mentioned in the class, is a measure of stickiness. All right, notice that has has no sign. There's no such thing as a negative coefficient of friction. So if it comes out negative, you're just going to take the absolute value. And it has no unit because a newton over a newton has no unit. So coefficient of friction, that measure of stickiness, because it's a ratio, also doesn't have a unit. Okay. And then the final thing that you're going to do is go ahead and answer these questions. All right. I hope that helps.